Hariom students, I hope all of you are staying safe at home. You maintain 2-meter distance away in public place. Today, what is the meaning of Samji saying, know your culture, then there will be a message in your activities and you will feel more fulfilled. Know your culture, then there will be a message in your activities and you will feel more fulfilled. അതായത് നമ്മുടെ സംസ്കാരത്തെ അറിയുക, സംസ്കാരം അറിഞ്ഞതിന് ശേഷം നമ്മൾ ചെയ്യുന്ന ഓരോ പ്രവൃത്തിയിലും നമുക്ക് ഒരു മെസ്സേജ്, നമുക്കൊരു സന്ദേശം അതിനകത്തുണ്ടാകും. നമ്മളുടെ ആ ഒരു പ്രവൃത്തിയില്ല ആ ഒരു നല്ല ഒരു സംസ്കാരത്തിൻ്റെ ഒരു സന്ദേശം നമുക്ക് പ്രകടിപ്പിക്കാൻ സാധിക്കും. ഇപ്പം നമുക്ക് കൂടുതൽ ചെയ്യുന്ന ഓരോ പ്രവൃത്തിയും നമുക്ക് പൂർണ്ണമായതായിട്ട് നമുക്ക് തോന്നും. അതായത് നമ്മുടെ സംസ്കാരത്തെ അറിയുക, നോ യുവർ കൾച്ചർ, സംസ്കാരം അറിഞ്ഞ് നമ്മൾ ജീവിക്കാൻ ശ്രമിക്കുക. അപ്പം നമ്മളുടെ ഓരോ പ്രവൃത്തിയിലും അതിൻ്റെ ആ സംസ്കാരത്തിൻ്റെതായ ഒരു നല്ല ഗുണങ്ങൾ നമ്മുടെ ഓരോ പ്രവൃത്തിയിലും നമുക്ക് അനുഭവിക്കാൻ സാധിക്കും. ഓക്കെ, then today we can study the rational numbers and their decimal expansions. In 9th standard you studied what is terminating and non-terminating decimals. If you divide a number, then a rational number, then if the for example 10 by 4 by 10. 4 by 10 is equal to 0.4. So here the decimal expansion is terminating. Here the 4 by 10 is equal to 0.4, that is terminating. Then 2 by 3. What is 2 by 3? 2 divided by 3. We can divide 2 by 3. Then 0. Then 3 6 are 18. Then 2 20. 3 6 are 18. Then 2. Then also 20. 3 6 are 18. Then the decimal expansion will never end. So it is called a non-terminating decimal. Here this decimal expansion is called a terminating. 4 by 10 we can write as 0.4. But 2 by 3 is 0.666. It is never ending. So it is non-terminating. 0.666 etc. This type of decimal expansion is called a non-terminating and this is called a terminating decimal. Okay. Then without actually dividing a rational number, we can check whether the rational numbers are terminating or non-terminating. There is a theorem. Let x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to m 5 raised to n, where m and n are non-negative integers. Then x has a decimal expansion which terminates. That is, if a rational number x is equal to p by q be a rational number, then if the prime factorization of q, that is if we factorize the denominator, if it is of the form 2 raised to m 5 raised to n, that is the factors, the denominators of the factors are only 2 and the powers of 2 and 5, then we can say that this decimal expansion is terminating. Otherwise it is not terminating. So let x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to m 5 raised to n. That is in the decimal the factorization of this denominator, it will have only the factors 2 and 5, the powers of 2 and 5. Then we can say that this decimal expansion is terminating. Otherwise it is non-terminating. Then if x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to m 5 raised to n, where m and n are non-negative integers, then x has a decimal expansion which terminates. Otherwise it is a non-terminating repeating decimal. Okay. Next we can do one question. Without actual division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating repeating decimal expansion. First question is, first one, 11 by 2 cube into 3. 11 by 2 cube into 3. Here you look at the decimal expansion of the denominator. The denominator is of the form 2 cube into 3. But if it is terminating, the denominator is, what is the form of the denominator, Badari? It is of the form 2 raised to m, 5 raised to n. But here it is of the form, not of the form 2 raised to m, 5 raised to n. Here one more term is there, here 3. So is the decimal expansion is terminating? So it is not terminating, it is non-terminating repeating decimal. So if the denominator is of the form 2 raised to m, 5 raised to n, only the powers of 2 and 5, then it is terminating. Here it is not of the form 2 raised to m, 5 raised to n. So what we can say, this decimal expansion is non-terminating. So it is non-terminating repeating decimal. Non-terminating repeating decimal. Non-terminating repeating decimal. What is the reason? Because the reason is the denominator is not of the form. The denominator, that is q. Q here, if p by q, if the denominator is q. If q is of the form 2 raised to m, 5 raised to n, then it is terminating. Here instead of q, here the denominator is 2 cube into 3. So the denominator is not of the form, not of the form 2 raised to m, 5 raised to n. So 11 by 2 cube into 3, here the denominator is 2 cube into 3. It is a non-terminating repeating decimal. Why? Because the denominator is not of the form 2 raised to m, 5 raised to n. So it is non-terminating repeating decimal. Then second one, 23 by 2 cube into 5 square. 23 by 2 cube into 5 square. You look at the denominator. Here the denominator. Kailas, is it terminating or non-terminating? You look at the denominator. The denominator is of the form 2 raised to m, 5 raised to n. The factors are only 2 and 5. The powers of 2 and 5. So what we can say, the decimal expansion is terminating. Here it is terminating decimal. It is terminating decimal. Terminating decimal. What is the reason? Because the denominator is of the form, the denominator is of the form 2 raised to m, 5 raised to n. Because here the first case 11 by 2 cube into 3, the denominator is not of the form 2 raised to m, 5 raised to n. So it is non-terminating repeating decimal. Second case, the denominator is of the form 2 raised to m, 5 raised to n. So what we can say, this decimal expansion is terminating. This is a terminating decimal. Then we can do the third one. Third one, 77 by 210. 77 by 210. The factorization is not given. So first we have to factorize it. 210 to 5 5 2 7 5 5. Then 3 7. Then what is of the form? Here 210. We factorizing, what we get from factorization. First we divide by 2, then 105. Then we divide by 5, then 21. Then divide by 3, then 7. Then what is the factorization of the denominator? The denominator. Denominator is equal to 210. That is equal to 2 into 5 into 3 into 7. 2 into 5 into 3 into 7. Then is it of the form 2 raised to m, 5 raised to n? Here the denominator is not of the form 2 raised to m, 5 raised to n. So what we can say? So this decimal expansion is non-terminating. Here the denominator is not of the form, the denominator is not of the form, 2 raised to m 5 raised to n. Therefore, it is non-terminating. It is non-terminating repeating decimal. So it is non-terminating repeating decimal. Here we factorize this 200, then 210 is equal to 2 into 5 into 3 into 7. Then it is not of the form 2 raised to m 5 raised to n. So it is non-terminating repeating decimal. Next question, 171 by 800. Here the prime factorization is not given, so first we have to factorize, prime factorization. Then divide by 2, 400, can divide it by 2, 200, then also 200, then also 250, then 225, then 5, 5. Here first we divide 800 by 2 is 400, then 200, then divide by 200, then we divide by 250, then we divide by 225, then 5, 5, 5. Then it is of the form, here the denominator is equal to, 800. We can write 800 as a prime factorization is equal to 2 raised to 5 into 5 square. We can write the denominator as 2 raised to 5 into 5 square. Then Hriday, is it terminating or non-terminating this decimal expansion? Here the denominator is of the form 2 raised to m 5 raised to n. So what we can say, this decimal expansion is this is the rational number will have a terminating decimal expansion. So to check whether the decimal expansion is terminating or non-terminating, what we do, first we find the decimal first prime factorization of the denominator. Here the denominator is we factorize the 800, we got 2 raised to 5 into 5 square. So it is of the form 2 raised to m 5 raised to n. So it is a terminating decimal expansion. Otherwise it is non-terminating. Okay. Here the denominator is of the form, the denominator is of the form 2 raised to m 5 raised to n. So the decimal expansion is terminating. The decimal expansion is terminating. So to check whether the decimal expansion of a rational number is terminating, first you find the prime factorization of the denominator. Here the denominator is 800. So we factorize it and we got the answer as 800 is equal to 2 raised to 5 into 5 square. So it is of the form 2 raised to m 5 raised to n. So what we can say, the decimal expansion of this 171 by 800 is terminating. If it is not of the form 2 raised to m 5 raised to n, then it is non-terminating. Here it is of the form 2 raised to 5 into 5 square. That is of the form 2 raised to m 5 raised to n. So it is a terminating decimal expansion. Okay. Show that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, where q is some integer. Then here we can take any positive integer a and b is equal to 6. Let a be any positive integer, positive integer and b is equal to, here what is b? b is equal to 6. Then by Euclid's algorithm, what is a? Therefore by Euclid's algorithm, a is equal to bq plus r. Euclid's algorithm, a is equal to bq plus r. Then instead of b we can put 6. Here b is 6. We are asked to show that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5. So here we take b as 6. Then a is equal to bq plus r. Then instead of a we can put a is equal to 6 cube plus r. Then what are the possible remainders if a number is the divisor is 6? Then what are the possible? R is equal, here r is equal to 0, 1, 2, 3, 4, 5. Here the divisor, the remainder is always less than the divisor. Here the divisor is b. Oh, it is 6. Then what are the possible remainders? The possible remainders are 0, 1, 2, 3, 4, 5. Then we can put the values of this 0, 1, 2, 3, 4, 5 in this. A is equal to 6 cube plus r. Then if r is equal to 0, what is a? A is equal to 6 cube plus 0, or a is equal to 6 cube. Then we can put r is equal to 1. If r is equal to 1, what is a? A is equal to 6 cube plus, instead of r we can put 1. Then if r is equal to 2, what is a? A is equal to, identity b, a is equal to, instead of r we can put 2. Then it is equal to 6 cube plus 2. Then if r is equal to 3, what is a? There we are, a is equal to b cube plus r, that is 6 cube plus r. Then if r is equal to 3, a is equal to 6 cube plus 3. Then if r is equal to 4, what is a? A is equal to, Sivanand, a is equal to 6 cube plus 4. Then if r is equal to 5, what is a, Sudarshan? It is equal to, instead of r we put 5. 6 cube plus 5. So, let a be any positive integer and b is equal to 6. Then by Euclid's algorithm, a is equal to b cube plus r. Then instead of b we put 6. A is equal to 6 cube plus r. Then if a number is divided by 6, what are the possible remainders? The possible remainders are 0, 1, 2, 3, 4 up to 5. Then if r is equal to 0, a is equal to 6 cube plus 0, or a is equal to 6 cube. Then if r is equal to 1, a is equal to 6 cube plus 1. If r is equal to a is equal to 6 cube plus 2. Then if r is equal to 3, a is equal to 6 cube plus 3. If r is equal to 4, a is equal to 6 cube plus 4. And if r is equal to 5, a is equal to 6 cube plus 5. Then here what is, show that any positive odd integer is of the form 6 cube plus 1. Then what are the odd integers here? If we add, here 6 cube is an even number. If we add 1 to this number, then we will get an odd number. Then this is an odd number, 1. Then what is another odd number here? This is even number. Then if r is equal to 3, then the even number plus odd number is equal to odd number. Therefore, this is also an odd number, 2. Then another odd number is, if r is equal to 5, it is equal to 6 cube plus 5. Then we got 3 odd numbers. What are they? First one, a is equal to 6 cube plus 1. Second one, 6 cube plus 3. And third one, 6 cube plus 5. Therefore, what are any odd integer is of the form 6 cube plus 1, 6 cube plus 3 or 6 cube plus 5. Therefore, any positive odd integer is of the form 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. Any positive odd integer is of the form 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. if you are asked to show that any positive integer is of the form, any positive even integer, then what are the form of even integer here? 6q, 6q plus 2, 6q plus 4. So, any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5, and any positive even integer is of the form 6q, 6q plus 2 and 6q plus 4. So, here we are using Euclid's algorithm to find the what is the division algorithm. A is equal to bq plus r. That is dividend is equal to divisor into quotient plus remainder. Here the divisor is 6. So we know that the divisor remainder is always less than the divisors. Then what are the possible remainders here? The possible remainders are 0, 1, 2, 3, 4, 5. So we put the values of 0, 1, 2, 3, 4, 5 in this equation. A is equal to bq plus r. Then we will get the values of A. Then what are the odd values here? The odd values are 6q plus 1, 6q plus 3 and 6q plus 5. So we prove that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Okay. So what we learned today, if to check whether a rational number, the decimal expansion of a rational number is terminating or not terminating, we first find the decimal the prime factorization of the denominator. The denominator is of the form 2 raised to m, 5 raised to n, then it is terminating. Otherwise it is not terminating, repeating decimal. So you remember it. So without actual division, we can find whether the decimal expansion of the rational number is terminating or non-terminating using the theorem. If it is of the denominator is of the form 2 raised to m, 5 raised to n, then it is terminating. Otherwise it is non-terminating, repeating decimal. So you remember it. Okay. We can do more questions in the next class. Assignments will be given through Google Classroom. Thank you and Hari you.